Hi there, everyone. My name is Dr. Marissa May, and we're going to be jumping in to the Mod 8 digital notebook. Now, if you're not familiar with my digital notebooks, it's just basically where I keep the notes for a section that we're going to be talking about. And today is all about perimeter and area. So if you would like a copy of my digital notebook, I'll be sure to put it down in the description below. We are going to be doing just the first part of this digital notebook. I didn't really want to get the videos to be too long. So I will be posting 2 more videos to finish out this particular group of lessons for the digital notebook. But today is going to be part 1, and I hope you enjoy. So let's jump right in. So here in my digital notebook, like I said, going to break this apart into 3 separate lessons with 3 separate videos. So if you will take a look, we're going to jump to slide number 3 here, where we start with perimeter. Now, perimeter is probably something that you're familiar with. It's a term that we use pretty early on in math classes where we're talking about adding up all the sides. Now, the thing that you have to remember is that each shape or polygon may have some interesting features, particularly like this rectangle that we have in this example. You know that rectangles have opposite sides that are the same. So the side of this rectangle here that's 10 centimeters is the same length as the side of the rectangle over here that's also 10 centimeters. And so we have to know those pieces so that we don't just look at this rectangle and go, oh, well, the perimeter is going to be 10 plus 18. Because the other sides are not labeled doesn't mean that we don't have to add them as part of our perimeter. So for this particular rectangle, we are going to add the 10 plus 18 plus 10 plus 18. We've got to include the sides that aren't particularly labeled in this case as part of our perimeter. And I'm just making that a little bit bigger for you guys to be able to see. Now, when we add those all up, you're going to get, put it in your calculator, 56 centimeters. Perimeter always has units just like those that are given. So for this case, 56 centimeters would be appropriate for our perimeter. Okay, let's go ahead and jump then to slide number 4, where we're talking about the area of a rectangle. And you can see that I gave you the area formula. This one, I'm guessing you might be familiar with, because again, we usually introduce this one pretty early on in our math classes. And so when we want to find the area of a rectangle, we're going to multiply the length times the width here. And in our case, that's the 20 times the 12. I'm going to pay a close attention, though, to those units. So I'm doing 20 inches times 12 inches. And the reason I'm making a big deal about the units is because I want you to see that we have inches times inches. And so when we write our answer, we're not just going to say 240. We are going to say 240 square inches or 240 inches squared. However you want to write those is fine. You just want to make sure that you're not just saying 240 inches. Area always have square units. So square centimeters, square feet. And you may have talked about this previously in another math class or in an earlier section of this math class where we looked at having square inches. So when we have inches times inches, that's square inches when we give our answer for the area. Okay, let's jump then to slide number 5. We're looking at the area of a parallelogram. This one may or may not be new to you. It's pretty simple though. We still multiply the base times the height. Now, looking at this particular parallelogram, I want you to see that the base is actually on the top. But in a parallelogram, here's a little side note, the top and the bottom are the same. Opposite sides are congruent, we say, in a parallelogram. So for this one, for this parallelogram, I'm just going to multiply the 30 centimeters times the 34 centimeters. And again, I'm making a big deal out of those units because I want you to see that we get those square units. So 30 times 34, going to pull out my trusty old little 4-function calculator, and I get 1020 square centimeters there for my units. Okay, pretty simple. One thing I love about our digital notebooks is this digital notebook has the formulas in it. So it's going to be something that while you're working on homework, you can go back and look at this digital notebook for your formulas that you may need for each of these shapes to do the area. Okay, let's go on to slide number 6 then. Slide number 6 looks at the area of triangles. And so I've got 2 different versions I want you to see of that area formula. You can do the base times the height and then divide by 2, or you can do 1/2 times the base times the height. Either one are going to produce the same answer for you. And so I give you both options so that you can use them appropriately. Just think about how you might make the problem simpler for yourself. Okay. So when we do the area for this triangle, the base is that bottom piece that's completely horizontal. That's 6 times. Now the height is that truly perpendicular piece. And I do want to put the centimeters in here, times the 5 centimeters. And then I'm going to divide by 2. And I'm just going to use this little slash for the divide by piece. Okay. So you can do 6 times 5 in your calculator, 6 times 5, and then divide by 2 to get 15. But I do want to draw your attention. You see that centimeters times centimeters, right? We still get square centimeters as my units for the area piece. Okay. So very important. I want you to see that with our area. Sorry about that. Um, then I put in another example here already worked out for you because I wanted you to see another way that the height could be used. And so that's something that, I'm sorry, another way that the height could be given. So I want you to see that piece of it as well. So I hope this lesson helps you as you're looking at perimeter and area and working those kinds of problems. Be sure to look back at your digital notebook for all of those good formulas that you're going to be using in your homework as well. Bye for now.